All right. Thanks, everybody, and welcome to our yearly multimeter training class. We do this every January. One thing is, no matter what, if you look at today's trucks, they'll only get more and more complicated. Is this going to make you an expert in being, using a multimeter? No, but will it help you? Yes. One of the best ways you can ever get good at using a multimeter is use it. So a lot of technicians, and I do this live, do it on the webinar, obviously. A lot of technicians have a tendency to use one or two functions on a multimeter. They don't always use them to their full advantage. So this is just, meant to be a good refresher, show you what all those different functions are. One of the biggest things I'm going to tell you too is, your multimeter may not look like the one we're going to show today. There's nothing wrong with that. But follow along with your meter. Again, when you get the recorded version, you can, pause it, go through it. Multimeters, for the most part, all do the same thing, have the same basic functions. You can get in more expensive meters or whatever that have more functions or whatever. I'm not here to sell you meters by any means. Two things I will always tell you about a multimeter. Don't go and be cheap, nor get on the tool truck and buy the most expensive one so you can have the coolest toy in the shop. Is buy a good one, but buy what you need. Don't get carried away. One of the biggest things I'll tell people too is, find a brand that has a calibration program. Just like a torque wrench or anything else, what are you supposed to do with them once a year? Send them in and get them calibrated, make sure they're right. So you want to, do some of your research on that. One of the brands that actually has a calibration program, so you can do that. But first, when we talk about a multimeter, what is a multimeter? A multimeter is a meter that does multiple different things. And again, technicians a lot of times only use one or two functions. There's a lot of functions on here. We're going to kind of go through them in order of the core functions, and also we have what we refer to as, helps if you move this slide correctly, what's maybe referred to as advanced functions, things you may not use very much. And a lot of people are on this webinar today, and you recognize a lot of names. A lot of you all compete in technician championships. Whether it's your state one or your intercompany one, or maybe TMC Super Tech. One thing I always tell you is if you do a tech event, one of the most important things you can bring with you is your multimeter. Is use the one you use every day you're most comfortable with. If you get to an event and you go to use a meter you've never seen before, you're going to waste a lot of time trying to figure out a meter you're not familiar with. So whether it's your meter, one at a tech event, you borrow your buddies, before you use it, you got to do some basic self-checks or meter checks. The first thing you turn it on, and again, depending upon brand of meter, the one we're showing right now comes up, it's got a little symbol, kind of looks like a AA battery. Some of them look a little shaped like a car battery. Some of them will actually come across the screen and say BATT. What all those indicators are telling you is the internal battery is low on that meter. If any of those symbols come on and stay on, usually it's part of a self-check, it'll light up for a second, then go out. But if it stays on, telling you your internal battery is low, before you try to use that meter, you have to change the battery. Now, if you notice anything that ever comes with, battery included, is it ever a good battery? No. I'm not here to sell you batteries either, but don't go down to the discount store and buy cheap batteries. You invested in a good piece of equipment. You don't want to take a chance on a cheap battery that's going to possibly leak acid and ruin your meter. See it all the time that, well, changed the battery 3 years ago, opened it up, and it was all crusty. Well, again, same thing. I always tell people that treat your multimeter like a smoke alarm. Once a year, change the battery. Make sure you got a good fresh one in it. The other thing you want to do is check your leads. Turn your meter to ohms, and ohms is a little upside down horseshoe or the Greek letter omega. Turn on there, touch your two leads together. It should zero out or come very close. If it doesn't, you either have a problem with your meter or you have a problem with your leads. And came up with a high-tech tool years ago, y'all know it as a paper clip, but you can use a piece of wire or whatever, take your two leads out, put that piece of wire to simulate the leads. That way you're checking just the meter. And it should zero out. If it doesn't, that tells you your meter's out of whack and you got to send it in and get it calibrated. You can't use, you always get some tech says, well, I just subtract the difference. It's like, do what? Well, if it shows 6 ohms and I check something that says 20 ohms, well, then it must be 14. It's like, no, you can't do that. The meter's got to be right. but we're going to assume it did 0. So now we can check our leads individually. Put just your red lead in, take the tip of it, put it where the black lead should go, and you're testing just the red lead. That way you can say, hey, are my leads good or bad? Is it both of them, one of them, whatever? Again, do the same thing with your black one. Take the red one out, put the black one back in, put the tip of it where the red should go, and you're testing just that one. The other thing you got to understand is what your meter's capable of doing. That most digital meters now are auto ranging. What does that mean? It says it's going to move the decimal to give you the most accurate reading regardless of what you're doing. 99.99% of the time, that meter is smart and all of us put together, leave it alone. It's going to give you your best reading very quickly. The one exception that I have found over the years is, especially if you get in very low voltages, sometimes automatic range is very slow to lock into a reading. So, and I'm talking, down the 2-volt range. So what you can actually do is take your meter, hit that mode button, and it'll turn it off from auto range and put it on manual range. And you can see it actually every time you hit that button, it'll move that decimal over. But it allows you to lock in, especially those low values much faster, more accurately. Now, this is again what we're talking about with automatic ranging. If you have a manual range, you're always going to have to hit that button or move the knob to get your best reading on it. But again, you have to make sure what your meter is capable of doing. Now, if you do take it off automatic range and put it on manual, the best thing I can tell you is turn your meter off, turn it back on, get it back on auto. Depending upon brand, the one we're showing you right now, if it's an auto, it says auto in the corner. If you put it to manual, that disappears and has no icon. Other brands of meters goes the opposite direction. If it's in manual, it says manual or MAN in the corner, and auto, it disappears. So again, you got to be familiar with your meter. The other thing you have to do is make sure you understand what the capacity of that meter is. Again, most meters will go to 1,000 volts. And that's what what we're showing you today will go up to. Depending upon brand, they may go a little bit higher than that, but for the most part, that's as far as they're going to read. We'll talk about if they exceed that here in a minute. And also, you got to understand when you're using the voltage part, which is going to be the first thing we're going to talk about here in a minute, is are you on AC or DC? Yes, they're both voltage, but the meter picks them up differently, so you have to put them on the right one. On the one we're showing, if you put the knob setting to voltage, it defaults to DC. And if you want to do AC readings, again, you have to hit that mode button. It'll toggle between AC and DC. Other meters may have a dedicated knob position, one for AC, one for DC. But again, you have to know which one you're using and make sure you're on the right one. Again, make sure you understand the range. Again, you get into the economy type meters. And again, I don't ever recommend you getting the one that came with a coupon in the flyer that either got a magnetic parts tray or a digital meter. You got to buy better than that if you're going to work on today's vehicles. But I have seen some of those that have a much lower range, and you get into some of the systems you may have on today's vehicles, they will not go high enough for you to do those tests. So we're actually going to finally use our meter now. We've gone through all of our self checks and meter checks, all those things, make sure we're ready. So for a voltmeter, the first thing we're going to do is we got a battery sitting there. That battery's at 12.5 volts or 12.5 volts. We put our red lead on positive, our black lead on negative. It's the only thing a voltmeter does. People think it's a lot more high-tech than it actually is. But what does the red lead read? Answer, 12.5. What does the black lead read? 0. You have 0 potential on the ground. So your meter displays 12.5. All it's telling us is the difference between those two different points. So now we're going to move on and get a little bit more complicated with our circuit. We're going to grab a couple of cables and a starter. The key right now, though, is no current is flowing. We just have that battery sitting there, 2 cables connected to a starter. Starter's not doing anything. So if I put my red lead on the starter positive, what am I still going to read? 12.5. I put my black lead on the starter ground. Still going to read 0. Difference is still 12.5. Now, in the circuit, since no current's flowing, I can move my meter anywhere I want to as long as my red's on a positive, black's on a negative. What am I still going to read? 12.5. Now, if I flip my leads around and put my black on positive, red on negative, what would my meter display? Negative 12.5. Does it hurt anything? No, meter's just sitting there telling you, hey, silly, you hooked me up backwards. Now, that's only true if it's a digital meter. If you try this with an old needle type analog meter, you can hook it up backwards. If your meter wasn't out of calibration before, guess what? It probably is now, because that meter needle tried to go the opposite direction. So you do have to be careful with that. Now, everybody always wants to use a meter red on positive, black on negative. Can I use a meter positive to positive? So I got my red lead on battery positive, my black lead on starter positive. What's each one going to read? Answer is 12.5. It sees the same potential on both ends. Doesn't hurt anything. And since we have no current flow, we don't have any voltage drop, so we're going to read 0. Now, if I had it hooked up like this right now, and my meter did display 12.5, what would that immediately tell me? I'm going to give you a second there to think about it. And the answer is, it would immediately tell you that cable has a break in it. Now, this generally would never happen on a big starter cable, you know, big 2-aught, 3-aught, 4-aught cable, but the same rules apply whether I was working on a, starter or the alternator or blower motor circuit or whatever. And we've done this on training boards over the years. And, what should happen at this point is, bells should be ringing, lights going off, everything saying, hey, here's your problem. But the most common reaction is 12.5. Ooh, that's good, move on. And they just skipped right over it. Again, it's telling you, hey, I must have an open in this circuit. Now, again, that could be a break in the cable. It could be a blown fuse, a switch that's open or whatever. But saying, hey, I'm seeing 12.5 on one side, I'm seeing 0 on the other. That's the only way you get that reading. Now, if I used a meter positive to positive, can I use one ground to ground? And the answer is yes. I'm still going to read 0 at the battery, 0 at the starter, because again, I have no current flow, no voltage drop. So I'm going to see 0 at both ends. Now we're going to get a little more complicated though. Now we are going to have current flow. For simplicity, we're going to show 2 different meters though. One across the battery, one across the starter. So my first one, going across the battery, what does my red lead read? 8.5. What does my black lead read? Still see 0 there, so I have 8.5 across that battery. Got my second meter over across the starter. What does my red lead read there? Answer is 7 volts. What does my black lead read? It says 0.3. So the difference is 6.7. So if I look at this, I have 8.5 at the start of my circuit with a load on. It's starter's engaged, it's cranking, pulling current. I got my second reading at the starter of 6.7. So how much voltage drop do I have in this circuit? Now, you can sit there and look at all, do some quick math, says, hey, I have a 1.8 volt drop in this entire circuit. Where is it? Well, you can look at that drawing for a while, or we can go back and use our voltmeter and look at each wire individually. So first I'm going to go across the positive. Again, I still got that same 8.5 at the battery. I still have the 7 at the starter. So the difference is 1.5. Now, we took algebra way back when, and we swore we'd never use that stuff. But what's the basis of algebra? If you knew 2, you could always find the third one. So if we had a 1.8 volt drop total in the entire circuit, when we had both meters up here, we just checked the positive, we got a 1.5. So how much does that mean we must have on the ground side? We do the same test, but go ground to ground. Difference is 0.3. So we got a 1.5 on positive, 0.3 on negative. If I was going to work on this truck, where would I start? Positive side. I got 5 times as much voltage drop on the positive as I do the ground. Now, what's the first thing I would do if I was going to work on this truck? First rule always is take things apart, clean them, tighten them, retest. That'll take care of most, issues out there. Just a lack of maintenance, corrosion. One of the things I see a lot of times is, someone changes the starter. They didn't put all the cables back up in the right stack. They're not getting the right connection. So yeah, take them apart, clean them. Now I got a thought question for y'all here. We just went through and we had a 1.8 volt drop. Is that good or bad? How many people are familiar with TMC RP129 spec? It's actually a voltage drop spec for cranking and charging cables. The spec is you are allowed half a volt at 500 amps. So is this truck good or bad? We don't know. Why don't we know? Because we have no idea how many amps that starter's pulling. Because if we're allowed half a volt at 500, how much voltage drop would we be allowed if we were pulling 1,000 amps? And the answer is 1 whole volt. If you pulled 1,500, you'd be allowed 1.5. Pulled 2,000, you'd be allowed 2 volts. So if you don't know what that current is, do you know if it's a fair test or not? Nice warm day, starter on a heavy duty truck may pull, 600-700 amps. That same truck in the middle of winter, when it's cold out and the engine oil is much thicker, it's going to pull a lot more current. We were checking a truck one time with a jump starter, and we had a starter that pulled almost 4,000 amps. It's like, whoa, what's wrong here? Well, it turned out 2 of the cylinders were full of water, blown head gasket or whatever. And did the starter know? No. Did the starter care? No. We hit the button to crank it. It did everything it could to try. So, starter is very power hungry, but we have to know what that current is. So what does a voltmeter do? It simply reads the voltage. How does it do it? By comparing 2 different points. And when we talk about voltage drop, the neat thing is you get familiar with using that function and doing these voltage drops. You can walk a voltmeter all the way around a circuit and says, hey, leave these other 5,000 wires alone. We know the voltage drop is between this point and that point. So voltmeter can do a lot for you if you get comfortable using it. All right, next thing we're going to talk about is an ammeter. And again, too, please do not hesitate. If you have questions, comments, don't forget to type them in. And again, I'll try to answer them. Ones that fit during the presentation. If not, we'll do them at the end. But don't be afraid to type them in. I promise I will not call you out on a question. So feel free to key them in at any time. But ammeter, what is an ammeter? An ammeter measures current. It's kind of like your water meter at your house. When they send you a bill each month, what do they bill you on? How many gallons? So they got a flow meter that tells you how many gallons is flowing. So what an ammeter does. 2 different types of ammeters we're going to talk about today. The first one is a shunt meter or an inline that is built into your meter. Most meters have a 10 amp rated inline ammeter. Before you try to use it, again, take your meter, put it on ohms, take your red lead, leave it in place right now, but put the point of it into that port that's labeled for your 10 amp function. If your fuse is good, it's going to give you a very low resistance reading. If it gives you something very high, but most commonly it's going to give you an OL, tells your internal fuse is blown. That one of the first things I'm going to tell you is these are not cheap fuses. They are special fuses. Most meters will also have a 400 milliamp function. I'm not even going to talk about it today because it is so low a current. One, there's no reason you'd ever have to be that accurate with that low of a current reading. The other thing too is it's so easy to blow that don't use it. 10 amps going to cover you. But the one on the right, that is a 10 amp fuse. It is a special fuse. It's what's referred to as a fast acting slow blow. What does that mean? It says it'll handle that 10 amps till the cows come home. But if you exceed it very much, what's it going to do? It's going to blow very quickly to protect your meter. Now, if you do blow your meter fuse, do not replace it with a Wrigley's wrapper. Do not replace it with a glass fuse out of your old Ford pickup. Do not replace it with a 22 shell. None of those are the proper replacement. These fuses, generally, you're going to have to go to an industrial supply, or you're going to have to get them off the tool truck. They're generally 15, 16 bucks each. So be careful when you use this function, because if you do one thing wrong in a split second, you're going to blow that fuse. But the biggest question people ask me is, where would I use this? Why do I care? What's this function ever going to do for me? Well, the most common answer is you got that one truck. Every Monday morning, batteries are low and it won't crank. So what's wrong with it? You got 1 or 2 things that could be wrong. You either have defective batteries, you got one with a shorted cell, and it's discharging, pulling the other batteries down, or more commonly, it's parasitic loads on the truck. I don't care whose truck it is. With the number of computers that are on today's trucks, not to mention the things fleets add to them, there's lots of devices that are pulling power from those batteries. Short periods of time, no big deal. But when we start getting in, especially all the holiday that we went through, Thanksgiving, Christmas, New Year's, we have trucks that sit longer, and those parasitics add up. We always say it doesn't matter if you get shot with a cannon or shot with a BB gun. If you die, you die. A small load left on long enough is going to kill the batteries just as much as a large load left on. But we're going to do a parasitic draw on this check, or parasitic draw check on this truck. Obviously, an oversimplified drawing right now. I don't know any truck out there that has one battery, one positive cable, one ground cable. So you got to think how you are going to do this test. We always say use the ground. It's just safer. When I say safer, that way you got loose cables sitting there, a lot less worry about dropping one and it touches a frame rail or something. But you do have to go through and get all your grounds. You may have one or two main cables going to the starter. You may have an alternator charge cable going straight to the batteries. You may have ECUs, cab feeds, whatever. You have to make sure you get all of those, bolt them together, and then make your connection between that and back to the battery negative post. But what we're going to do is we're going to put our 10 amp fuse in line first. And the reason we use a 10 amp fuse with a fuse holder is if it is more than 10 amps, it's going to blow that one. You can go back to the parts room and grab another one and recheck. If you blow the one in your meter, that comes out of your pocket and you're going to have to, again, track down the tool guy or whatever. So we put that in first. It does not blow. Okay, we're safe. We're ready to put our meter in line. What I always tell people to do first is put your meter in parallel. That means you leave your fuse in, and then you connect your meter along with it. Now, thought question for you here. This would have been a great poll question, should have put in. But with the way it's connected right now, if you had a 2.5 amp load, what would your meter display? Give you a second to think about it. But I have my fuse holder in line and I have my meter in line. We know we have a 2.5 amp load, but what would our meter display? Answer is, actually it was on the screen. Basically 1.25 or half of the overall load. Why is that? Because half is going to go through the fuse holder and half is going to go through the meter. Once I take that fuse holder out of line, now it all has to go through the meter. Why do I bother saying all that? Because what if you missed a ground cable? Especially if it's a big 2-watt battery cable, it's going to flow through that big 2-watt battery cable easier than this is a meter, and you're not going to get an accurate reading. So you have to make sure you have everything disconnected. So we've confirmed we have a 2.5 amp load. Are we done? No. Now we got to figure out what it is. All we know is, yes, we do have a load. How are we going to find it? Start pulling fuses. When you pull out the HVAC fuse, nope, still there, put it back in. You pull out the courtesy fuse, for the under dash lights or whatever. Ooh, it went away. It's like, wait a minute, I got the door open. Of course it's going to disappear. Of course I got a load on. So you got to make sure, you got all those devices turned off so you're getting an accurate reading. The other thing you got to be very careful about using an inline meter like this is we had to break the circuit. We disconnected power and reconnected it. So what did every device on that truck just do? They all rebooted. We talk about communication systems, whether it's, a Geotab or a Qualcomm or whatever, those all generally have some sort of a step down to them. When they first power up, they're going to look for messages, send messages, whatever. Then they go into a standby mode, and eventually they go into a sleep mode. If you don't understand what those steps are, and you do an immediate reading, says, ooh, I got a huge load here, I got problems. Well, 20 minutes later, those communication systems may go to sleep and that load disappears. It may take 30 minutes, it may take an hour. So you do have to be careful that you don't, create more work for you by not understanding, that you did just reboot all those things. Again, bad thing about an inline is we had to break it. So the next type of meter we're going to talk about is a clip-on or an inductive meter. And the way it works is anytime we have power flowing through a cable, that's we use what's called the right-hand rule of electricity. That if you look, this would be a power cable. From the left is the batteries, and off to the right is the starter. That's the direction current's flowing. If I put my right hand on that cable and put my thumb direction the current's flowing, look the way your fingers wrap around it. That's why it's going to generate a magnetic field. And that's what that inductive or clip-on ammeter is going to read, is that magnetic field. Now, there's things that are great about this type meter. There's things that you have to be very careful of. One of the nice things, most of these modern ones now have a 0 button. So before you put it on your wire, we always recommend, flick the clamp a couple times, because they sometimes can generate some static electricity, which will give you some weird go signals. So clip it a couple times and hit the 0 button. It'll zero it out. If you have an older piece of equipment, a lot of those have what was called a thumb wheel, where you had to push it in and turn it left or right to zero it. Those are all such a pain, because you'd go from -10 and jump up to +15. Was very hard to ever get it zeroed out. So the newer type ones make it much easier. But a couple of things you got to be careful about. If you don't get the jaws closed all the way, is it going to be accurate? No. The other thing is direction of the current flow. We talked about that right-hand rule of electricity. If I put it on the cable backwards, is it going to hurt anything? No, but it's simply going to give you a negative symbol. So if you're checking an alternator and it said, negative 150, does that mean the alternator's sucking 150? No, you probably just have it put on backwards. So you just have to be aware. The other thing is, again, is it's read that magnetic flow or magnetic flux. If I went around both the positive and negative cables together, the two fluxes would basically cancel each other out. Same thing if you had a big harness and you're trying to get a one wire. It's always safest to pull it away from all the other ones. Try to make sure you're not picking up flux from other ones. And just like anything else, when we talk about clip-on ammeters, you get what you pay for. These things go anywhere from a milliamp type clip-on ammeter that's very, very accurate in low current. It's going to have a much smaller hole. It's going to have better shielding, everything for lower current. Versus there's some that go up to 2,000 amps. Both of them are good, but if you've got one that's rated at 2,000 amp, it obviously has a much larger jaw, and it's not going to be nearly as accurate on low current. Also, too, one of the biggest things you got to be careful of, see it in a lot of shops, is people try to go down to the home improvement store and buy one. Most of the time you buy one at a home improvement or even a electrical wholesale place, most of what they sell is designed for electricians and is going to be at AC. You try to use it on your truck, it's going to give you, bad readings at best. So make sure you are buying one that is a DC. There's many of them out there in the marketplace. If you have questions, whatever, just like anything else in the presentation, don't hesitate to reach out. We don't sell them, but we can give you recommendations of what you could or should buy. And that same thing is, again, we have the live Q&A, but even, next week, feel free to send me an email or send me a text, whatever. Ask questions. We are here to help you. So again, what's an ammeter do? Simply reads current. And again, one of the most common things is checking those parasitics. What is something pulling? Okay, we're going to move on to our next function now, which is an ohmmeter. Every time I go to shops, they'll say, ask people, you know how to use an ohmmeter? Oh yeah, I use it all the time. I'm great. All right, let's give you a quick test. Again, another place should have put in a poll question. I was a little worried about time today, so I do still have a question though for you. Is you're checking you got a service bulletin and tells you to go check the XYZ sensor. The XYZ sensor should have a reading of greater than 6K. The spec basically is all they're looking for is a reading larger than 6K. You grab your meter, you go out there, put it across the XYZ sensor, and this is the reading you get. Is that sensor good or bad? Give you a minute to think about it. And again, they're looking for greater than 6K. The answer is the sensor is good. What that meter's not telling you is it's not telling you 5.46 ohms. It is 5.46 with a big M ohms. What does that big M mean? It means 10 to the 6th power. So not 5.46 ohms, it is 5,460,000 ohms. That's a lot of those little critters. Again, all that service bulletin was looking for is what they considered an infinite or an open reading, something larger than 6,000. Obviously, 5 million is larger than 6,000. If you don't believe me, I'll be more than happy to trade you, 6,000 for 5,000, dollars. But if you don't understand what that meter's telling you, you can very easily replace components there's nothing wrong with. One of the other things you got to be very careful of is, again, showed you that little clip on ammeter. There's some of them that have a quote-unquote multimeter built into them, which does give you some basic functions, but I've seen several of them that the ohmmeter function only goes up to 4,000 ohms. So if you're trying to test the sensor, you can't even accurately test it because it doesn't have enough capacity for even what the spec is called for. So you have to be very careful. We're going to go through several more of these, just a quick ohmmeter. This one comes up 99.0 K. We don't have an M. This time we have a K. What does that K mean? That would be 99,000 ohms. Do another one here. We got 9.58. We're back to the M. So that is 9,580,000. And just as a reference, in the reference section of this, we do have a meter cheat sheet card that you can print out that kind of explains all these things too. So don't forget that it is there for you. This one, 0.990 M scale, at a quick glance, you're just shy of 1 million. The other thing too, as a good reminder for you, if you do tech events and you have to write down things like this, if you don't write them all the way out, you will not get credit. And the reason that is, well, when my son was 10 years old, he could write down what the screen said. Did he have any clue what it meant? No. Another one here, 9.76 K. So it's 9,760 ohms. 21.7. So 21,710. Go through these a little faster. This is one that always stumps people. You got 0.546 K. How many ohms is that? And the answer is it's just 546. Most meters, if it goes over 500 ohms, it automatically puts it on the K scale for some reason. Don't know why, but they do. The other thing too is people ask why they put a K and M, because nobody wants to buy a multimeter that's a foot wide to have enough digits to display it all. So they have to abbreviate it, not only for the screen, but also for manuals. 3 more to go here, 14.85. Again, it was a K scale, so 14,850. This was kind of like the other one we just had. It's a 0.983. We know it's just under 1,000 because it's a K scale. Then the last one, 3.239 K, so it's 3,239. And one of those things is you get more and more familiar with the meter, these things just jump at you. You get, right now you're having to think, what's a K, what's an M, what do they mean? Like everything else, that the more you use your meter, the better you're going to get. So if you do have a test light, don't throw it away. I know you paid too much for it, but take it home. Don't use it. Force yourself to use a meter. Okay, we're actually going to use our ohmmeter. Do some testing. Now, one of the easiest things to test on is a 5-pin relay. Every truck's got a whole bunch of them. They may be square like this, they may be rectangular with smaller pins, but a relay is a relay for the most part when we talk about what we're going to check on one. If I was going to check on, what's the first thing I would check? I'm going to go across the 2 coil connections or terminals. This one we go across says we have 102 ohms. Is that good or bad? Well, the slide says good, so it must be good, right? Well, how did I know it was good? I had to go back to the manufacturer's spec sheet and say, hey, this particular model, what should that resistance be? It was, spec was between 100 and 105 ohms, so I know this one's good. So I'm going to grab another one, check it. I go across it, I get an OL. What does that tell me? Somewhere in the coil of that relay, there's a break in the wire. I don't know if anyone's ever taken a relay apart, but there's a little metal core. It's got tons of loops of, small wire around it. How many loops? I don't know. I tried to count them once, got bored. But I'm going to say there's 400 loops. Somewhere in those 400 loops, there is a break, so it cannot, does not have continuity, and cannot generate that magnetic field it needs to make the arm inside the relay move. So I'm going to grab another one, check it. This one obviously is not open, but look at the resistance. It is much lower resistance than that spec is. What does that tell us is wrong with it? Again, we talk about those 400 loops. Somewhere in the middle of all those loops, we have two coils are touching, so it's not going through all 400 loops anymore. It's only going through about 200 loops. And if resistance goes down, what must go up? So if you look at the math using Ohm's law, on our first example on the left, we had 12.5 volts. We divided it by 102 ohms. So that coil should pull 0.12 amps. That's what it was designed to handle. Now, why is all this important? Way back when, I know that the first time I ever had to do anything with a relay is I had an old 76 Chevy pickup, and I wanted to put some fog lights on it. So I went down to the parts store, got me a fog light kit. In the box was a relay and a toggle switch. My first thought was, why do I need this relay? You wanted to toss it over my shoulder, say, no, wait, what's it supposed to do? The whole idea of a relay is we can control a high current device with a low current switch. Before, everything was very basic. You had a 12-volt switch that activated that relay. Now what controls relays? Some sort of a control module, SAM, body controller, or an ECU, but it's something that controls it. And it was designed to handle that 0.12 amps. We take that same relay that's got a shorted coil, though. Again, if resistance goes down, current must go up. So we went from only, excuse me, pulling 0.12 amps to now we're pulling 0.23. It's almost twice the current. So what's going to happen? Well, it could damage the module because you're trying to pull too much current through it, or that module may simply shut down and says, hey, too much current, so we shut off that output or whatever to protect ourselves. If you don't understand what that relay's doing and why it's doing it, what's the most common reaction for a technician? Well, it's a bad module. So you run the risk of someone changing out of $300, $400, $500, $600 module or more, when what's actually wrong is a $3 relay. So you have to understand that. And again, you see a lot of technicians in the shop, if they think they got a bad relay, what do? They find one they think is good and they swap it. Well, one, you probably just moved a problem. So again, it's much more than just, part swapping or whatever. A meter will flat talk to you and figure out what's wrong. So we did all of our checks on our coil of it. What else can we check? We can check the contacts. The first we have is a set of, if it's a 5-pin, you have a set of normally closed contacts. We can use our ohmmeter, go across those, says, hey, those contacts are closed, which they should be. And at the same time, you can check your normally open, check those, and you should have a very high resistance saying, yes, they are truly open. Now, that's just with the relay in your hand. What you could also do now is energize that relay, and your normally closed would now be open, and your normally open would now be closed. So you can check, make sure that arm is doing what it's supposed to do. Now, if you really want to check this relay, though, what would you do? We'd put it back in service, turn that device on, again, use the blower motor as example, turn that blower motor back on high, take our voltmeter and do a voltage drop across that. Because again, if you've ever taken a relay apart, you'll see the contacts in there are very, very small, maybe 1/16 of an inch across those contact areas. Most relays energize or open and close a live circuit. So every time that relay opens and closes, what happens across those contacts? You get arcing. And so if that relay's been in service for years, how many times is it open and closed and pitted out those contacts? So you can wind up with a high resistance connection with inside that relay because of that. So again, you can use your voltmeter to go across it and check, the condition of those contacts. If you've ever seen a power distribution module that, is starting to look melted or deformed, a lot of times that's what it is you've got a coil that's staying engaged that generates heat, but now you also have high resistance contacts that are also going to generate heat. And changing out a power distribution box is not a quick project. So, those are things to keep an eye out for. And hey, we may look and says, hey, this, relay that we know handles a lot of current, maybe we ought to change those once a year, no matter what, just to prevent that from happening. So, sum up, what does an ohmmeter do? Simply reads resistance. Okay, a couple other functions that we're going to talk about is a diode check. What is a diode? For the most part, when we talk about a diode, it is an electrical device that allows current to flow one direction, but not the other. Now, there are exceptions to this. We lump diodes all into one group. There's probably hundreds of different types of diodes, different ratings, different, standards. Some diodes will allow current to flow different direction based on a voltage or whatever. But for the most part, we're going to talk about it as a device that, flows one way, but not the other. Again, when we talk about our meter, you have to make sure you're familiar with your meter. Look on the screen, you should get a little diode symbol on it. The meter we're using, the diode check, continuity, ohms, and capacitance is all one knob setting. So again, you have to use that mode button. You may have to toggle through, make sure you're on the right setting. But if you're not on diode check, it is not a proper diode check. If you use ohms, will it test it? Yes. Is it right? No. So anyway, we got on diode check. Got a diode here we're going to go through. This is actually a big diode out of like a Greyhound bus alternator. Makes for a much easier picture than something off a circuit board. But current should not flow this direction, so we get an OL. But if we swap our two leads around, now most meters will give you a beep or a little chirp, and it'll give you a numeric value on the screen. What that value actually is telling you how much voltage drop is across that diode. All diodes create voltage drops, so you always have to be careful if you use one for something. A lot of times they're using what's called a battery isolator, where you have one charge source that goes to two different battery banks. Very easy way to do it to separate two battery banks. The problem is that inherent voltage drop is going to limit the voltage the battery banks get. So you do have to be aware of that. Or if it's a sense wire or something else that, it is going to give you a lower voltage than what it should be. Next one, we got another diode we're going to check. Go across it. Doesn't matter which direction we put our leads on it. All we ever get's an OL. Tells us that diode is open. It's not allowing current to flow either direction. Next one, doesn't matter which way we hook up our leads on it, we always get a continuous beep, and we get all zeros saying that diode is shorted, that it will allow current to flow either direction. Years ago, when we were in the starter and alternator business, going through the first days or the first years of Series 60 engines, we used to see a lot of diodes fail in alternators because of the vibration. And they would always fail in a shorted position, so it would create a parasitic draw on the system. Now, again, using that same function or knob setting on your meter, along with diode check and our wonderful beeper we have, there's also a continuity test. Now, continuity test can be a wonderful function that, hey, I'm checking a wire from point A to point B. Is it still connected? So, yes, it does a great job of telling you that. The bad thing is people think because it beeps and shows continuity, it means that wire is good. And if you look at the two pictures there, that the top one's a piece of 10 gauge wire. Every strand but one has been broke. Will that wire show continuity? Answer is yes. The bad thing is that wire cannot handle any current. Same thing, we got another wire down below that somebody stabbed with their test light. It's got water, chemicals, whatever in it. It's green and fuzzy. Even though it's not, splayed out like the wire above it, that wire is in no better shape than the one above it. Will they still show continuity? Yes. Can they handle current? No. The other thing you got to be very careful with when using continuity check is electricity is lazy. It will find a path back. That does not necessarily mean, it's going the right way, or you're only checking its only path. I see it happen a lot of times with trailer techs. Is they think they got a wiring problem on a trailer. If you go to the nose of the trailer, for example, and you put one lead on yellow and one lead on green, your meter is going to show continuity. It's going to beep or whatever. Why is that? First reaction is a harness is shorted or grounded or whatever. I say, wait a minute, there's nothing wrong with that harness. What do you mean? Again, electricity is lazy. You can show continuity going through the filaments of the bulbs if it's got incandescent bulbs on it. Most LED lights won't let that happen, but if it's incandescent, it definitely will. They will find that common path back through ground. So you have to be very careful. The other thing is anything that has a relay, it can go through the coil back to ground and show you that something is quote unquote touching or whatever that truly is not. A good example is that relay. Relay has a power side and a ground side. If you went on the power side and touch chassis, will it show continuity? Again, people's first reaction is, it's grounded, it's shorted, whatever. Well, it simply went through the relay coil back to ground. So one of the biggest things I tell people is grab you a paper and a pen, draw out the circuit. Think about anything that's, could give you those examples, which would be, again, a relay. Any type of a solenoid or mag switch, starter solenoid, those all have coils in them. What is an AC clutch? It's a coil. So you may have to disconnect things and go back and recheck because it can give you false positives very easily. Some of the next things we're going to talk about as we wrap up, we only have 11 minutes left, but again, feel free to type in any questions. Hold function. Now, any of you that have met me in person before know I'm not always the most coordinated person. So you can imagine me trying to hold meter leads and use a camera, take all these pictures we used. Not going to happen. What hold allows you to do is if you're going across a battery or going across a sensor, whatever, you can use that hold button and it's going to lock in whatever the reading is. That's very handy. Again, you're going back through and checking those sensors, or probably one of the most apt to make this handy is something like a temperature gauge. That a temperature gauge's resistance reading changes based on the temperature. So you may have to take that resistance and go back and find the table. Says, well, if it's this temperature, the resistance should be this. If it's this temperature, resistance should be this. So it makes it very handy for you to lock that in. Min-max functions, whether you're looking at, the voltage across the battery pack, hey, I hit the starter, what did the voltage do? When it cranked versus what did it do when the engine started and the voltage climbed back up. It allows you to see the minimum reading it saw and also the highest reading it saw. One I actually think is, even cooler than that, though, is relative function. Basically, it allows you to zero out your meter. So if you put your meter across the batteries and said it was 12.5 volts, you can hit relative. It'll take your meter back down to 0. And whenever you hit the starter, whatever it displays is going to tell you how low that voltage dropped when you hit the starter. So if the batteries were at 12.5, you crank the engine and it dropped down to 10.5, your meter is going to display 2 volts because that's what the difference was between the two. So again, very handy for a lot of functions. Pulse width modulation. This is something we hardly ever used before, but now it's on everything. Pulse width is basically a device being turned off and on very quickly to limit it. And some of the first applications, this was fuel injectors. That whether you're quarter throttle, half throttle, full throttle, how long was that injector turned on and how often. Now we do it for everything. Blower motor used to be a blower motor resistor. It had 3 different resistors that gave us 3 different speeds. Now with pulse width modulation, basically we can have infinite speeds. That, if we want blower on 50% speed, if you look at pulse width, it's on half the time, off half the time. Same thing, volume. If you see it on a lot of cars now, especially if you use your phone and try to capture a video, it looks like the tail lights are blinking just because of the frames per second. We'll show it as a blinking light versus our eyes will pick it up as a solid on light. But to use that, you just use the percentage function on your meter if you have it. Frequency, if you're in a fleet that has sleepers, obviously it's very common to see inverters in them. Inverters are like anything else. You get what you pay for. If you buy an economy inverter, or an inverter that starts to fail, a lot of times the frequency will go kind of haywire. Everything in the US, 110, 60 hertz. If you were to check one and you got a big discrepancy in that, you may say, hey, that inverter's starting to fail. That can affect the performance, whatever you got plugged into it. Other things that it can impact is things like microwave ovens. They actually, the clock is adjusted and kept up to date by the frequency it sees. That's one that was kind of a surprise to me of what frequency we did for us. All right, and the last thing I'm going to show you is that meter cheat sheet we talked about. This is available in the references. I do ask you, please do not drop off yet. We got a couple of housekeeping things, plus we have a survey for you. But yeah, feel free to print this off. It's also on our website. The other thing, if there is interest, this is a training board that we use also as a test board. Again, there is a huge need for more training in electrical. Trucks are obviously getting more complicated every day. If you look at the new trucks, one is obviously the growth in the EV market, that we're not just talking about 12 volts anymore. Now we're talking about really voltages that are considered lethal. Some of the new trucks now are going 12, 24 volts. So obviously it's getting much more complicated. Before I do let you go and turn it over to the housekeeping portion, we do ask you to register. It's the best way for us to keep track of who's attending these. If you look in the resource section, again, there's that shortcut to the online tests and certification. I believe it's 27 questions. If you get at least 21 right, it will generate a training certificate, so you can turn that into your boss. There's no limit on how many times you take it, so feel free to take it over and over. And anyone that's in a management or supervisor role, if you'd like, we can do reports for you. Who is on this training, whether it was live or they watch it a week from now or whatever, we can give you some feedback on it. And same thing with the test results. But in the survey section that's coming up, we want input. We try to do these things to be a service to our customers into the industry. So if you have ideas for presentations or webinar ideas, anything that we can do to help you, gives you a good place to give your feedback there. And then also to my contact information, if there's anything else we can do to support you. So thank you all for attending, and hopefully I'll see a bunch of you in a couple of months at TMC.